So for internal use only, but sharing with our colleagues who couldn't join. So just so everyone is aware that that is happening. But again, welcome, Ralph. Let me ask you, the first question is, how did you discover the Object Lessons series? How did you come to write for it?
Uh, yeah, so I'm one of those hopeless academics that sits in the ivory tower and produces paper after paper, and nobody ever reads them. And so this has kind of bugged me for a while, and I tried to find different outlets on how to communicate the information that we're collecting at Arizona State University. And so we've tried different things. We did TED Talks, and we do other events. We go to schools, we do all kinds of stuff. But one day our chief writer at Arizona State University dropped in and said, "I've heard that you got interesting stories to tell. Why don't you have 30 minutes to sit with me?" And that's Stephen Beschloss from Arizona State University. He's the director of creative writing there. And so we sat down and I told him a little bit about where I'm coming from. I grew up in Germany, and I was trained as a biologist, and we had a flood of biologists at the time, so I was unemployed and had to leave the country and go to the United States and start over as an engineer, and became an environmental engineer, and then ultimately I ended up in public health and then at Arizona State University. And but I always had an interest in the environment and in protecting it, but I saw that the studies that we were doing weren't, very effective. And so Stephen, extracted some of the stories that I had to tell, kind of the scientific data out of me, and said, yeah, there's probably something that we could write up. And I believe the same week, he introduced me to Chris Starberg, your editor, co-editor, and then I was told that there's a writer workshop that very weekend. So it was like 2 days after we met, I believe. And so I partook in this writers workshop that is conducted at Arizona State University. And so we sat down and wrote short, I think 1 page of a story as an outline. And then we critiqued that. And being from Germany, I'm very used to critique, so I love people going over stuff. And so we reviewed each other's writing, and that then ultimately developed in the idea of doing a book with the hook that it was April 2020 and April 2019 and April 2020 would be Earth Day. And I had thought that I wanted to do something for Earth Day 2020, which is the 50th anniversary of Earth. And so I challenged Chris and Steve to maybe move a deadline a little forward, and rather than take 2 years for a production of a book that wasn't even written, to produce it quickly. And with Harris's and everybody else's help, we actually got it done. And so I wrote the book over the summer, and there it is. And now it comes out at a very unique time in American history and in global history. For the first time, we are in a state of globalization. We see our planet disrupted in all socially, economically, and healthcare-wise by a pandemic that is caused by a virus. I think a lot of people don't even know what a virus exactly is. Is it alive? Is it, how does it work? But we do know, no matter what it is, that it affects us. And it's interesting, the coincidence that I wrote this book a year ago because I felt that there is a misconception between people looking at the environment and looking at their health. And there's always, when somebody looks at their life, they look out and say, oh, the environment is, is you're polluting. They see this as something that is external. And through my studies, we have, I run an analytical lab at Arizona State University, and we analyze samples from the environment and from people. And so I'm used to seeing the same bad stuff in the environment first, typically, and then in people. And I have an interest in children. I have 3 children of my own. They're 20, 18, and 14, going 14, 13 in a little bit. And so when I was at Hopkins, I started to study babies and exposure to babies. And so we obtained samples from the placenta, from blood of the placenta, that is the afterbirth material. And so essentially could take a look at what babies experience, before they even have taken the first breath. And we found all those contaminants that I had previously observed in the environment. So it became clearer and clearer to me that the environment and us is really the same thing. And it's very difficult to communicate that. At least it was until the pandemic hit. And now we realize that you, Abby, are my environment and and I am your environment. And we have to be separated by this technology right now because we are, exposing each other. But that exposure is really taking place all the time, everywhere. And I think in the book I mentioned that there's the chemistry, permeating through us at all time, and we give our chemistry at the same time too. And we know that from, if you wear a perfume or something, or an aftershave. But we give off a lot of chemistry, and we absorb chemistry constantly. And so we are interacting with our environment. And, and when we put our children on their, home mattress to sleep, they can rest up to, 18 hours, 16 hours on a material that is soaked with, hormone mimicking chemicals. And it is just incomprehensible when you get insights into the process and into the exposures and into the effects that these exposures have, that nothing is happening. And that's what's motivated me to write the book and do it, rather quickly. And I wish I had more time. It would have turned out better, but it is what it is. And I'm happy that it's there. And so you guys are the judge. So that's how the book happened.
I think it turned out pretty great. Although it is shocking, some of it, this idea that, all of these things that we think are outside of our bodies, these plastics and these chemicals, and they are in us. Sorry, kind of new participant. So why don't you talk a little bit about some of the things that you talk about in the book? We talked a little bit earlier about, some of the topics I found really eye-opening, but
maybe well, let's start out with, how I typically address my students in class, and that's, who hates chemistry? Please raise your hand to your camera. Is there anyone who doesn't like chemistry, who doesn't take a chemistry book to bed? Yeah, that's most of us. And that's intriguing to me because chemistry is the building block of everything. Responsible for everything you see, for your body, even for your emotions and for your behavior. So these little chemicals that nobody cares much about are really dictating who we are, what we look like, how long we live, and how we feel and all that. And that's amazing. The disinterest. Hello, my friend. Do you like chemistry? So he can't hear me. Okay. The fact that a chemistry or a science that is so essential, you get so little appreciation. And I think one of the objectives was to do a stealth chemistry lesson with this book, so that even people who are not interested in chemistry at least would get an understanding of how far-reaching it is and how much it impacts everyday life. So that was the idea. I think it wasn't all that stealth because some readers already have committed that they easily flipped over certain pages that were loaded with the dates of banning of different chemicals that all looked alike. And everyone was surprised when we removed one after another. But if you look at it from a logical perspective, well, if this chemical looks like this and it's bad, then, its twin brother or sister, which looks almost identical, is probably just as bad, and that's how it turns out. And so that was one of the reasons of just telling stories around chemistry. And the book takes us then, for those who haven't read it, to outer space. Maybe it starts there as a teaser, and then brings us around to objects of our daily life. Think of a plastic bottle that's actually on the cover of the book. So floating in the water, and all the other contacts that we have with plastics, and this dangerous chemistry that we do know exists and that is being regulated is present everywhere, including in our food, and of course in our drinking water. and ultimately we put it into our bodies, and it accumulates in our bodies. And so it's a journey of discovery, tracking chemicals that we emit into the environment, only to discover that we emit them into ourselves. And if anything you want to remember from this talk or from this conversation is maybe that think of the Earth and humanity as the amniotic sac and the fetus therein. So the fetus in the amniotic sac is actually breathing the urine and the fluid. It's all going through the baby all the time. We do the same thing here on our planet. We are emitting things into the atmosphere that we cannot escape. And so I liken this to creating an ever-thickening soup of chemistry that we're destined to live in, and not only us, but generations to come. And the large irony is that when we began to more stringently regulate chemicals in the with the inception of the US EPA in the 1970s, we developed an appreciation for how much harm can be done. But rather than designing safer chemicals, we actually have made things worse by moving from stuff that already was bad to the worst case scenario and replacing some of the chemicals that we have banned with other stuff that looks like ironclad toxins that will be here until the end of time. And so I'm talking about your Gore-Tex, membranes and all these polyfluorinated Teflon-like chemicals that we create for convenience, and that is really it's a miracle chemistry because it works so well. It repels water, it repels oil, it's breathable and so forth. But it also creates a chemistry that nature isn't prepared for. And that means that it will be in our amniotic sac, our atmosphere, in our life forever. And that is really sad, and it's difficult to communicate because people just don't, it's difficult to gain an appreciation for chemistry and an appreciation for the need to protect the environment, because ultimately you're protecting yourself. And that's kind of what I try to communicate with the various stories. And so we go into water, we go into food and fish, and look at how chemicals can go on a long journey to end up in your ahi tuna sushi that you're consuming. And I don't know if we have time, we can walk one of these chemicals through. Yeah, Harris?
Yeah, I was just going to say that there's a strange and interesting story in the book about the food inspector that you met. So perhaps you can tell that.
Good. You want me to read it, or you want me to I think just explain it, right? Yeah. So that was a really eye-opening story happened. And so I had a graduate student of mine was interested in studying food safety, and she set out by looking at the antibiotics that we feed fish in order to grow faster and in order to be able to put them in very high density so that we can harvest a lot of fish in a short period of time in a small place to make it very efficient. That is called aquaculture. So rather than going and catching fish in the wild, we do aquaculture. And today, most of the seafood that you find and that you put on your dinner plates is actually coming from aquaculture. And so while we were engaged in that study, we needed fish and seafood that's representative of the stuff we find on our dinner plates. And so we made connections to a person in Phoenix who is a food inspector. And that person works, and if you've ever been in Phoenix, it gets really, really hot here. So, and we don't have an ocean. So seafood and the desert, they don't go hand in hand. But amazingly, we learned that a lot of the seafood that is being consumed along the Western USA is actually going through Phoenix. And so it flies into the desert, out of the ocean, flies into the desert to only then return to other places. It's really bizarre. And so this food inspector showed up in our office, and we asked him, so why are you doing this? Why do you want to help us? And he said, well, I got a personal story about this. And he told us that he had very severe health issues in the past years. And they got so bad that one day he was driving back from his job at the Phoenix airport and was driving home only to discover, if you know about the geography of Phoenix, if you go west, eventually you hit the Pacific Ocean. He was going the wrong direction and was heading to California, and almost was on the outskirts of Phoenix before he realized that something was wrong. And he was able to collect his thoughts and go back, but clearly he was very confused, and there was something seriously wrong with him. And so the inspector went and saw his doctor. And the doctor did different, asked different questions, including, what type of food the food inspector eats. And that's really important. And that's something that we typically don't consider. How much food is dictating our health and our mood and everything. We are concerned about, a plastic bottle, that it might, ooze out chemicals. But we are putting, large quantities of chemicals into our body. And that's really a primary source of modifying our health and shaping it in a better or in a worse way. Anyway, so the food inspector revealed that he is in the food inspection business at the airport, opening packages of tuna and swordfish and so forth, and removing small pieces of that. And then he's left with the rather large servings that don't need to go to inspection. And so he made it a habit of having a little cool box in his office, and was shuttling, the leftovers home, and then was doing barbecues in the evening, eating mostly tuna and swordfish. And for somebody like me working in environmental exposure, we know that is not a good idea. And I think if you're female and you're facing or in pregnancy, you see the warnings that you should not, eat a lot of fish, of seafood, particularly, species like swordfish and tuna, because they tend to accumulate contaminants, and a lot of them are neurocontaminants and neurotoxins. And so it turns out that the food inspector ate tuna and swordfish in large quantities. And by doing so, he poisoned himself with mercury. And the mercury levels were so high that he needed to go through chelation therapy to essentially capture the chemicals that were already stored in his body and make them, water soluble so that he could pee them out and get rid of them. And so he kind of, flushed most of the heavy metal out of his body and became acutely aware of how important food is for our health, having had this horrible experience. So he recovered almost completely. Mercury is a neurotoxin and has significant impact on the human body. But he recovered fairly well after getting rid of most of the what we call a body burden, so the chemical mass that is stored up in your body. And so that gave him an interest in helping us out, and so he sent us more samples of seafood, and we studied antibiotics and flame retardants and all the other chemicals that we know are being produced, but where we often don't know how far they travel. And the interesting thing about the food inspector and the mercury is that, of course, you wonder, where's the mercury coming from? And so the mercury is actually part of coal. And so humanity in its hunger for energy, goes and digs up the Earth's crust, brings up the coal, sets it ablaze, sends the mercury into the air, and then long-range transfer with wind brings it all around the world, and it rains down with precipitation. So that explains why some of the contaminants that we are concerned about are actually present in very remote places, like the Arctic and Antarctic, the polar regions. And so when the mercury rains down then at ever increasing concentrations, because we are burning more and more coal, particularly in China, it then gets transformed by microorganisms to add a little appendix to it, and that makes it more sticky to fat. And as you might have observed, we all get bigger, and the humanity is on a binge of into overweight and obesity. And so when the sticky mercury ends up in the human body, it clings to the fat and is accumulating there. And so that's why the food inspector wasn't just, giving off the mercury he took in by consuming that swordfish fillets. but that it was storing up the mercury. And the source of it was essentially our hunger for energy, and our kind of ignorance to the fact that an element like mercury cannot be destroyed. So if we make a conscious decision to dig up bad stuff in the Earth's crust and bring it into what we call our chemosphere or our biosphere, then we get exposed all the time. And so elements cannot be destroyed. Mercury is there forever, and if we get it out of its sequestered place down in the Earth's crust into our living spaces, then we get exposed. And that's what happened to the food inspector, and he did help us in measuring a lot of other chemicals that we were able to detect in seafood, including antibiotics, and that raise drug resistance in microorganisms and create pathogenic and potentially lethal bacteria. And so, yeah, that was just one of the stories of kind of a personal story of a inspector who you would expect. It's ironic, right? You would expect that this person has all the knowledge and skills, but it also, I think, it illustrates how much we can compartmentalize information, how we can be at the office and do one thing, and then we go back home and we kind of completely disregard what is happening in another place. I don't know why that is. I'm not a brain scientist, but it does happen, and it doesn't serve us well, because obviously the information is always true no matter where you reside. And if we forget about it in one location and not observe the threats, then we're putting ourselves needlessly at risk. Yeah. Other questions or observations, or Abby?
Yeah, I have a few questions. So there are the sort of harmful toxins that we can't see and that are difficult to create a sense of alarm and urgency, among people at large to try and do something about. But then there are, sort of the really big obvious things like plastic. But we don't seem to be doing a lot better on that front either.
Yeah.
I mean, so there's a couple of questions. One is, it'd be interesting to get an explanation about what microplastics are and your involvement with helping to bring that to light. And the sort of second thing is recycling. So you talk a little bit about recycling, not a great deal, but a little bit in the book, and it's not all of all that sort of positive a picture about the effects of recycling. But anyway, those two separate things would be interesting to hear more about.
Okay. Well, let's start with plastics, right? And remember The Graduate. The plastics are the future, right? Dustin Hoffman in his famous role as a graduate, and and so nothing much has happened. Polymers are still ruling the world, and if anything, we have just increased the production since that film came out, and so plastics are everywhere now, and it's a classic example. Typical, it's analogous to the situation with mercury. I mentioned that elements like the metals, they cannot degrade. They are there forever. You can only move them around, and if you decide to mass produce a chemical that is essentially indestructible from the perspective of microorganisms, then you end up with a similar situation where whatever you make sticks around. And that's kind of the story we're in, knee deep with plastics that are accumulating everywhere. So you can, no matter where you look, you see plastics. And we discovered the gyres of circulating, plastic debris in the oceans, and thought, wow, that's pretty bad. You have remote places in the Pacific and the other world's oceans, and and there is the plastic debris accumulating. That's really just, the tip of the iceberg, because the plastics you see there for everyone to see, there's thousands and millions of little bits and pieces, which we call microplastics, that are invisible for the most part. And the smaller they get, the worse they are potentially for human health. And so that got a lot of press, the microplastics. And so people started to look for microplastics in different places. And lo and behold, we found them just about everywhere. So it turns out that in the air over a city like New York City, there's huge amounts, tens of thousands of particulates of microplastics are in the air, in the breathable air. So we know that these chemicals, these polymers, get into our body. And the microplastics are a little different than the other chemicals. When you look at other chemicals, you study them on a molecular basis. So you think, this shape, where does it fit into the body, and how does it, modulate metabolism? But with the microplastics, it's more like a foreign object that gets into your body. If you're lucky, it goes into your mouth and you swallow it and you poop it out, and it's without consequence. And the next, kind of wave of scientific papers that examined exposure to plastics and found them in our food and found them in our, excreta. But that's not really where the real risk is, because if the polymer, if the fragment is so small that it can exit the GI system and get into your bloodstream, that's where the real problems start. Because then it enters into your circulatory system and can be, get stuck and move around in your body, and potentially ending up maybe in a filtration organ like your liver or your lung or your kidney. And I think we all know what happens if we have a foreign object in our hand, right? When we work in the yard, the body doesn't like it. So it reacts, it puts up a defense, and that typically results in what's known as inflammation. And inflammation, to any oncologist, is known to be the precursor of cancer. We know this from asbestos, so a mineral, just a material that is known to cause cancer from inhalation. And so there's very little information about the plastics and their impact on and ability to cause inflammation and cancer. But one thing's for sure, we use so much plastic that is everywhere. Why is that? It's not because of us, right? Because we recycle. You said it, Horace. We are all good people. When we buy that water bottle, we put it into that blue bin, right? And it gets collected. Well, that's awesome. But the ugly truth is that we have been fooled by the plastic industry for decades, because we created this recycling system, which in reality translates to a collection of a potentially valuable material, but absence of the machinery and the know-how of how to put it back into good use. And so, as you might remember, there was a big problem when China refused to take back all that plastic that they were sending us in shipping containers. We used to take the new goods and then send the plastic waste back to China. And a year ago or so, they decided, well, let's put an end to this. And so now we are sitting in our own plastic waste, and we recognize that we don't have the recycling machinery in place. And even before, it wasn't really recycled; it was just shipped back, oftentimes to resource-poor countries that don't even have a solid waste handling stream. So send it to Indonesia. Well, they don't have trucks going around bringing it to fancy recycling facilities. So Indonesia is mostly a coastal environment. So a lot of the stuff ended up right next to the ocean, and it was blown and washed into the ocean. And there was a continuously ongoing process. And so that's essentially where we're at. So look at the plastic that you consume as something, as an unhealthy material. It's very poorly designed. I mean, it's just about every design flaw that you could integrate into making it has been observed, and it can be studied there. And so we are creating a material that is incompatible with natural degradation processes. It's incompatible with the degradation processes in our body, and it cannot be recycled effectively. And it's made from fossil fuels, a limited resource, the use of which also adds carbon dioxide to the atmosphere. So it has just a lot of adverse properties, and yet we are hooked. We are addicted to plastic, and we're using more and more of it. And so when I look at this from a scientific perspective, my impression is that what we need is to create a different relationship with plastics. It's not good enough to have the knowledge. I mentioned before that you can compartmentalize. You can, read a paper and know, oh yeah, plastics are bad. And then you go back to the fridge and everything that you get out is in plastics, and plastics is everywhere, right? And so what needs to happen is that we need to change our emotional reaction to plastics. So I'd like all of you, next time you sit down on a dinner table, if you see an object of plastic on the table, remove it. It doesn't belong into the environment of eating, into the environment of putting things into your body. And I think if we would all do that, we would drastically reduce the amount of plastics. We would ask manufacturers to please package things differently, or not package them at all. There's no need to take a banana and wrap it in a plastic foil, right? It's perfectly packaged by nature in recyclable package. And then we mess it up by adding other layers of non-degradable material. But that is a really sad story, and we don't have really good answers for that right now, because the plastic industry is just as addicted as we are, not to the materials, but more so to our money that we pay for it. So it's a very good, huge revenue stream, and it's also a very big industry. If we were to change the plastics we make today, we would have to retool the machinery which we use to make it. Since we make so much, we have a lot of machinery. So this is a huge capital expense that would come our way. And that prevents the industry from being really motivated to deal with this problem. And so what we're seeing is something that's called greenwashing, meaning that they pretend to do the right thing, they pay lip service, and then do something else. And that's what we're engaged in right now. There's even, a lot of nonprofits popping up that try to control plastics. I think most of them, if not all, are well-meaning, but sometimes this is just the same process that we've seen with smoking and, the cigarette industry, where we're trying to delay as much as possible the very necessary step that will, save lives and that will get us out of this misery that we're in. And so these are, plastics are a huge problem, and it's a visible problem. That makes it attractive as a pollutant, because oftentimes the little mentioned mercury you can't really see unless you break your old thermometer that still contains mercury. And the plastics are visible, and you see the ugliness of it as well. If you go for a walk, a stroll, along a river, and you see all the plastic bags hung up in a high water zone on the trees and accumulating in the sediment and on the shore, it's just ugly. And that ugliness is translating into an unhealthy environment and a shortened lifespan for the biota out there as well as for us. So that's another big topic. I'm waiting for more questions, but you're all muted, so let's see who's brave enough.
We've tried to reduce our, plastic purchases. You go to the grocery store, your spinach is wrapped in plastic, and your squash is wrapped in plastic, and it is actually so difficult to avoid it. But it is possible. It's alarming right now with the coronavirus and everything that's going on, and it actually feels like, maybe it's my alarmist nature, but like that we're going to see this boom in plastic use because people are going back to their plastic bags and they're buying plastic bottles of water, and it's actually really scary to me to think that there are certain people who have made all these efforts to reduce our plastic, but actually in one foul swoop we may be going the other way. It's not really a question, it's more a comment.
Yeah, but you bring up an important point. We are in the middle of a pandemic, and right now the most important thing is to shield ourselves from the virus and from infection. And that takes place with the use of a lot of non-reusable materials that we have, that help us to control that exposure. So in the short term, I think it's all right if we use these plastics, just as all right to use bottled water if you are, in a situation where an earthquake occurred and all the pipes are broken and no water is arriving, right? Or the water is not safe that arrives at your home. But in general, it is clear that this is completely unsustainable. And if you look at the amount of waste, when I go to New York City, all the people take pictures of all the buildings. I always take pictures of the trash. It just amazes me how when I walk and then there's these trash piles. And I don't know what your waste collection days are, but they are. I mean, I'm 6'4", and this stuff is just twice as tall, and it seems endless. And you look down the street, and this is wow. I mean, how is we make so much of this stuff, and where does it go, right? And unfortunately, a lot of the materials we use have no place to go. And we don't expect that the consumer, take responsibility for that. And we still need to buy safe food that needs to be packaged. We have to communicate that we are unhappy. And that creates a market, and that creates pressure. And we also have to ask some tough questions, right, to the recycling industry. And remember that the recycling industry and the solid waste industry, they're all the same. Like if you look at large companies like Waste Management, they own the landfill and they own the recycling center. They make good money with the tipping fees from the landfill. They don't have a big incentive to get rid of landfills and make everything circular and reusable. So there's an infrastructure issue, a structural issue that prevents us from moving on more quickly, and that's a big challenge to overcome. But the consumers are, whether they know it or not, they're in the driver's seat. So it's you and me who make the decisions, and if we voice our dissatisfaction, then we are on the right path to a better future.
I'll open it up. Does anyone else on the call have any questions? Not everyone's on video, but you can unmute yourself and ask anything you'd like.
I got a quick one.
I have a question. No, go ahead, Matt. No, Matt, go ahead.
First? All right. I mean, I just wondered, I know we've been talking about a lot of the negatives here, but I was wondering if you've seen anything in the last 2 years that might be a glimmer of hope that people are moving. I mean, I understand the first part is raising consciousness, but then the second part I think would be action. So I wondered if you saw anything that was a little bit more like hopeful, or ways that, or even if on a sort of a second question, are there simple ways where on a person-to-person level we can kind of have our own agency to do something about this and not feel like you when I walk down my street on garbage day and feel like, oh my Lord, there's no way, how are we ever going to get away from this problem?
Yeah, I'm glad you're asking that question, Matt. So I tried to, and I did conclude the book with a more hopeful outlook. And it's, after giving you a lot of bad information, feeding that to you, it ends in an epilogue where, I step out of my home and go for a run in the morning, which I like to do here. And I live in Phoenix, and weather's always nice. And I decided a couple of years ago to put a solar power system on our house. And I always felt like it's not the right time, because I saw that the cost was always going down, the efficiency was always going up. I'm an engineer, I could see, well, if I wait a year, I get twice as much for half the cost, right? So when is the right time? So eventually we say, well, let's do it. And I installed the solar power system. And the outcome of that was that we make more energy now in our home. It's a simple 4-bedroom single family home. We put these panels on the roof, and they cost us the tax credits, about an amount that we can pay off in seven years. And I have essentially zero energy bills right now. I pay a little bit to be on grid, okay, but I have so many panels on the roof that I have extra, which I sell back to the grid. My last 3 energy bills, since we don't have to cool right now, they were all negative. And over the course of the year, I saw last year that I have so much energy that I could buy an electric car. And you might have similar, reservations about electric cars. I live in Phoenix. I really like the ocean. If I could, I would live on the ocean. I would take Arizona State University and put it, right next to the Pacific Ocean. But with an electric car to travel all the way to California, it's a hard thing to do. So we bought a hybrid car that is a plug-in hybrid, where you can travel for 26 miles. And that sounds horrible. 26 miles a day, that doesn't get you anywhere, right? But it turns out we bought the car like 3 months ago, and we still run on the first tank, and it's almost completely full. Because all the runs we do are really short, and all we do is you plug it into your household, outlet, 110 volts. It didn't even need a rapid charger. And when when it's hot now, and we go to the thermostat, and we dial in the temperature we feel comfortable with, It's energy that comes directly from the sun. And, we are independent of anything else. And we can set it to whatever level we like without having a bad conscience. And so these are examples where it really makes a difference. And these are, scalable big things. So when I drive here and I see communities develop that look exactly like the ones we made in the 1970s, that's absurd. In a place where the sun shines 300 days out of the year, right? But it just illustrates that the obstacles and barriers and how companies, even non-profits, even the utilities, how they protect their turf to cling to this business model rather than, actually envisioning and living toward a better future. But it's doable. And so we essentially got, hooked off the utility and the dependence on that. And the next thing that I looked at as an engineer, I always try to find the biggest lever in my home, which is the one that I can pull that has the biggest impact, right? Well, and if you're honest, I'm a scientist. I traveled to a lot of places. I did a lot of air travel. So then I, calculated my carbon footprint and the energy and emissions, associated with that. And that's the biggest thing. So, it's good to be essentially energy neutral, even negative with your home. But there's other steps we could take. And when I wrote the book, I could not imagine that we could turn the corner, that we would be willing to do less travel. But look at where we are right now. We have a perfectly fine, exchange of information and over large distances without a huge carbon footprint. And I hope that some of this will stay with us once, the restrictions and ordinances have been lifted, because that is the sure way of changing it. And maybe the good in this ongoing pandemic, as horrible as it is that we got a preview of how much we can actually change and how we can, get out of a pattern of behavior that we are just feeling it's normal. And all of a sudden we notice, hey, we can work a completely different way. We can have family dinners again where everyone is doing something. We sit down and we actually have time for each other. And I think that all of these things, hopefully have an impact. So I see a silver lining, but I also know that it's a daunting challenge to run up against, the corporations and short-term gains that are always, typically getting us into a very long and painful, experiences down the road. Yeah, there was another question.
Yes, I had a question. So you mentioned earlier that you could kind of time the book to come out around the 50th anniversary of Earth Day. And earlier on in the book, you mentioned sort of the founding of Earth Day being in part due to Rachel Carson's legacy. And in fact, you have a whole chapter in the book about Rachel Carson. I was wondering if you could give us like a background on her work and how it's impacted what you've done with the book and in your work in general. And I don't know if you have any thoughts on what she'd think about where we're at today in terms of pollutants and things like that.
Yeah. Thanks for bringing that up. Obviously, I mean, Rachel Carson was a huge figure, that really changed our perception of and interaction with the environment, and it has ultimately improved all of our health through, the giving, essentially helping to bring to being the United States Environmental Protection Agency and the Clean Water Act and so forth. I worked in Maryland, in Baltimore, not far from Rachel's birthplace, and so I had an opportunity to go there and give a speech on, I think it was the 45th anniversary of the release of Silent Spring. And if she was around today, what would she say? I think she would be disappointed, and I think would have a hard time to believe that we, after all this knowledge, have not moved on. And we have to realize that when she wrote her book, there was a lot of intuition. There was she had inklings about certain things. There was not a lot of data on some, of the outcomes that she observed. And this has definitely changed. And so we have found much more mechanisms that can explain why we see a reduced biodiversity that manifests itself in the loss of songbirds and so forth. But still, as I said previously, we are in this regrettable substitution business where we ban one chemical and then the next one pops up, the same impact, the horrible effects, and we're not breaking that cycle. And so my hope is that we are awakened by the current situation, that changes our behavior and our understanding of the environment, and also gives us an appreciation of how fragile everything really is. Because before everyone had their job and you were just worrying about little things. And now, you realize this is really elemental stuff, fundamental stuff that you cannot, see your family members and that you cannot just live a normal life. And it's all linked to the environment. And so we have to take care of that. We have to be just more careful and more protective of the place we inhabit. Other questions?
Another question is, yes. So a lot of us here in New York live in apartments and stuff. What would you suggest to do in terms of that? Going back to your stuff about how you put a solar panel and stuff on your roof. How would you suggest us living in apartments do that?
Yeah, so the difficulty with living in an apartment is that you don't control your environment as much as if you own a home and you can determine what building materials go into it and all of that, if you can construct it or if you remodel it. I think most of the ground rules apply. You look at your front door, your apartment door, or the door of your home as a lock, where when you walk through, you make sure you bring only in the stuff that you really want in there. So you don't want to bring in, a lot of toxicants because you bring them in a small confined space and, they will come around. Think of like a 5-gallon container of gasoline. If you store that in an attached garage, then the gasoline is off-gassing and you have a carcinogen in the breathable air in your home. Similarly, when you buy furniture, carpets, curtains, all these kinds of things, ask questions. It's amazing how uninformed the salespeople and the producers of materials are. They have no idea what's in the stuff that they're selling. And so I think if consumers would ask questions, so what do you know about the composition of this material? Is it degradable? Is it endocrine disrupting, right? The truth is a lot of these things are flame retarded, although they don't need to be flame retarded to that degree, and they are, harmful. So asking these types of questions when you make purchases that involve textiles and other goods, I think can be very, very helpful. Another thing that is in the book and that has gained a lot of relevance right now is this approach of getting a very rapid measurement of a larger population, using the effluent of a community as a diagnostic matrix. And people do this in medicine, right? Where, if you're sick, you deposit urine and stool at your doctor's office and you expect that you get an accurate diagnosis of, what's wrong with you. And so we discovered that you can do the same thing by tracking the wastewater that we are producing, because essentially it's the same material, just with a little more, shower water and bathing water and, mixed in. But it's the same, kind of chemical signal that you're still emitting from your body. And so we demonstrated that you can measure the wastewater of a population, be it an apartment building or a campus or a school or a part of a city, a neighborhood, or even a big city, like a really big city like Mexico City or New York, and can determine very quickly what's going on there, what people eat, how much they smoke, what types of illicit drugs are in the city, whether the illicit drug consumption goes up or down. All of this, can be observed. The opioid crisis, we developed the first dashboard to display real-time information on, the amounts of heroin by neighborhood in our hometowns, Tempe here. And we meet with the mayor's office every month to discuss that. So there's huge opportunities to look at this type of information flow. In an ideal world, I would say, in the future, we should build buildings not only that are energy neutral or negative and have solar power, systems on their roof, but also that have by default an access point to the wastewater, so that the wastewater coming out of your apartment could routinely be measured, and we could see that there are, for example, releases of harmful chemicals or of molds, that cause sick building syndrome. All of this can be done now. It is just an underutilized technology. And it's very expensive to measure, the individual exposure of every apartment inhabitant. But it's very easy to take one sample and then look at the combined average chemistry and exposure. And that's, you might have read about this, is also happening with the SARS-CoV-2 virus now that causes COVID-19. It's apparent that we don't have the testing capacity to test all the people and repeatedly to see whether they have recovered and whether they got sick again and so forth. And the wastewater really stands out as a very promising way of doing these types of assessments of where the threat is and where it isn't and where it goes up and down trend-wise can be done. And so I am waiting today, hopefully, to get notice from the National Science Foundation that they will fund our proposal to measure not only the virus that causes COVID-19 in the city of Tempe, but also the impact that it has on our health. So, because we can observe stress hormones and, dietary deficiencies, all this is detectable in wastewater. And what an experiment this is on a global scale. We are locking down communities that, and put them into unemployment and furlough and deprive them of access to food. This is a really stressful time. And interestingly, we have collected data 2 years leading up to this. And now we can compare what we call benchline data, that go also the baseline data that go seasonally over the different temperatures, and can compare that directly to the situation we're finding us in right now. So I hope that we find federal funds to pay for this and learn our lesson and then move on, and that the next apartment building you're going to move into has that access hall and it says wastewater-based epidemiology, sample here. That's the ideal outcome.
Thank you.
You're welcome. Other questions, comments?
I had so one of the things that you mentioned in the book was that you had done a review of the time lag between the discovery of scientific discovery of a pollutant or something that people shouldn't be exposed to, and then obviously the length of time it then takes from there for anything to be done about it is a pretty depressing part of the book. You could talk about that if you like, but this is a larger question is then the work that you do and other scientists do, what then happens after the work is done and published, and then from there for anything else to happen after that, and your experience of talking to lawmakers, for example.
Also promise me that we don't end on that note, because an analysis of how long it takes from the moment you know that something is wrong, you have the data, until something is done by the federal government, that is really depressing. And if you want to venture a guess, be my guest. It is not days or months. It is not 1 year or two. It's on average 14 years. 14 years between identifying that something is horribly bad and harming people until you find in the Federal Register, an ordinance or whatever, a law that regulates that. And then it takes another 14 years for this concern over the chemical to disappear. So it's a very long process and it's inefficient. And so we got to that number of 14 years by analyzing in a meta-analysis, so in a very large study of studies, looking at 143,000 different papers on contaminants, 143,000 papers. And after we've analyzed all those, we found, wow, it's on average, it takes 14 years to have this regulatory change. That obviously is too long. It's actually immoral, if you think about it, to expose, future generations and, pregnant women and all that over, multiple generations to these types of chemicals without taking action. Yeah, so that's frustrating, and but it brings us to why we have the book and why we need more, I think, more media coverage that brings attention to the fact that there are a lot of threats in our developed world. Because not only do we have all these privileges of being, living in the developed world, but we also suffer a lot of adverse health outcomes that are sometimes unknown in populations and places in the world where we don't use a lot of plastic and we don't have fast food dietary kind of patterns. And so that's what we're up against. It's a very slow process. What we need is better communication. We need better ways of connecting to this. In my many years of studying contaminants and trying to communicate the need to do something, I have found that people care very little about the environment, and that you have to make it personal. And that's why the premise of the book is the environment is you, and if you don't take care of yourself, you pay the price. We tend to relate more to ourselves, and as parents, we even relate more to the health of our children. So we take the health of our children more, seriously than our own health. So you might be a smoker, but you watch out that your kid, eats healthily. So knowing that and observing that has convinced me that we have to create, a messaging way of getting information to people that they can personalize. And so the studies that I publish, they are useless as communications tools. There has to be a different way of getting that information to people so that they can feel it, that they have an emotional response to that information. Yeah.
Is there an example of that, like where it's been done the right way, something's been discovered, it's been communicated in a way that's effective, and then it has been sort of dealt with?
Yeah, so the biggest victory kind of was the Montreal situation where we got rid of the chemicals that the propellants that were used in bottles and hairspray and so forth, CFCs that were degrading the ozone layer, right? And so that from the moment where this study was published in a high impact journal, there was a very rapid move, by politicians to do something, and they did it on a global scale, which is very difficult to do because you get all these different governments with different interests. So the Montreal Protocol is an example of how this could be done, and could be done at scale, and could be done rather quickly. That was one of the brightest moments. What we see is that it becomes more and more difficult the more money is linked to whatever the risk is. And we have the same, kind of yin yang right now with the virus, where we are itching to reopen our economy, but from a public health perspective, we know that we have to wait out. We have to let this wave go. We have to build up the capacity. When you see these plots of healthcare capacity, they are always flat. That's not how it really is. What's happening is that we are building up capacity for more beds and for the healthcare system to absorb more patients and bring them back to good health. And the longer we wait with reopening our business, the better the capacity is of the healthcare system to deal with the next wave of infections. And so that's what needs to happen. And these are examples of how we can do it right, and it can be done. Yeah. Other comment?
A positive note we're coming up on 1 o'clock, so we can end it there. Thank you so much for spending this time with us and for writing this book. And we'll do our best to make sure that it gets out there and people can read some of these.
Please do make it your Christmas present for anyone who has a birthday in April and any other month of the year. It is equally relevant. Yeah, thanks for the opportunity to speak. I'm really happy that I could make this. I was supposed to be obviously there in person, and everything got canceled. But it's good and it's fun to do these things even remotely. So I appreciate it, and all the hard work they put in producing the book in record time to make it accessible in time for Earth Day. So thank you, and be healthy and stay well.
Thank you. Well, you too.
Thank you.
Thank you.
Bye, everyone.
Thank you.
Bye.
Thank you.
Bye.